All right, in this video here, we're going to continue talking about the unit circle, but talk about the reference number for a t value. Right? So if you haven't seen the other videos that I've done on the unit circle itself, on what we mean by a terminal point, on some of the special terminal points, the ones on the x and y axis, as well as the ones in the first quadrant, I would advise you to maybe watch those videos before you look at this one. In this video here, we're going to kind of take some of that stuff we talked about before, and this one is going to focus more on, well, how do we use that stuff to figure out terminal points in other quadrants, right? So this video and then the next one I'm going to do will focus more on, taking the things that we learned about the first quadrant and things that we learned with the trig hand, which if you didn't watch the video I did on trig hand, you should check that out as well, and how to apply that to other quadrants instead of just the first quadrant, right? So in order to do that, we use what we call a reference number. All right, so the reference number t bar, right, which is the letter t with just a line over top of it, we call it t bar. So the reference number t bar associated with t is the shortest distance along the unit circle from t's terminal point to the x-axis. All right, so again, if you watch the other videos I did, hopefully you recall that the t value is giving us a distance that we travel along the circumference of the unit circle. We're just going around the circle, t units, whatever t is. If t is 5, we always start on the positive x-axis, and if t equals 5, we just keep going around the unit circle, keep going around that circumference until we've traveled a distance of 5 units. Right, so that's what our t value represents. Right, so the t value could take us into any one of the quadrants depending on what number t is. All right, so the reference number, the t bar, is once we travel that distance around the unit circle, around the circumference, t units, we stop. That's our terminal point for t, right? That point, those x and y coordinates of that point on the unit circle, that's what we call the terminal point for that t value. And then from that t value, the shortest distance to get back to the x-axis, that short distance we call the reference number, right? So, and I put up here 4 different examples, depending on which quadrant we're in, of what t bar, what the reference number would look like, or graphically what it represents. So if our t value is in the first quadrant, right? So if our t value is kind of a small number and we don't travel very far, so if we travel the distance of t along the unit circle, we're still in the first quadrant, well, the shortest distance back to the x-axis is just back along that distance we already traveled. So in that case, in the first quadrant, t bar equals t, right, which is what we see up here, t equals t bar. Right, so if we're in the first quadrant, I haven't gone very far along the unit circle, the shortest distance back to the x-axis is just the same distance I already traveled. So t and t bar are exactly the same when you're in the first quadrant. Right? If your t value takes you into the second quadrant, like in this example over here, right? So again, when we're traveling along the circumference, remember we always start on the positive x-axis, right? My t value, that's how far I travel along the circumference of the circle. That takes me over here, and I stop in the second quadrant. Well, to get back to the x-axis, going back the path I traveled is not the shortest way to get to the x-axis. If I just go from this point over here to the negative x-axis, that's going to be shorter than going all the way back around that way. And so when we're in the second quadrant, the t bar is just taking us from the point where we stopped and then continuing on until we get to the negative x-axis. All right, so that's what t bar looks like when we're in the second quadrant, is from wherever that point ends and then just kind of continue on until you hit that x-axis again. All right, so that's t bar for quadrant number 2. If our t value takes us to quadrant number 3, right? So our t value is, we're traveling around the unit circle, we end up in quadrant 3. Well, the shortest distance from a point in quadrant 3 to get back to the x-axis is traveling back along the path you came until you get to the negative x-axis, right? So here, t takes us all the way around the circle, more than halfway around the circle into quadrant 3. To get back to the x-axis, I just need to go back this little distance here. That's the shortest way to the x-axis. That's my t bar, is that little black, part of the circumference of the circle right there. Right? So again, the t bar, the reference number, is always the shortest distance along the unit circle. I can't just go from here straight up to the x-axis, right? It's always traveling along the unit circle, but the shortest way to get us to the x-axis from our terminal point. So our terminal point is in the third quadrant. I'm not going to travel all the way along here to get to the x-axis. It's shorter to just go back this way to hit the x-axis. All right, so that's my reference number for the third quadrant. And if I'm in the fourth quadrant, all right, if my t value takes me, more than 3/4 of the way around the circle, but not quite all the way around, I end up in the fourth quadrant. And from a point in the fourth quadrant, the closest way to get back to the x-axis is just continue on until you complete that full circle. All right, so if you're in the fourth quadrant, the t-bar, the reference number, is the distance from your terminal point back up to the positive x-axis. All right, so again, t-bar, the shortest distance along the unit circle from your terminal point to the x-axis. Remember, it's always the x-axis. You would say, well, for this one, it's maybe closer to go to the y-axis. The terminal point is always in reference to the x-axis, never the y. All right, so that's a common mistake people sometimes make. They say, well, it would be quicker to get to the y-axis this way. You're always going to the x, never the y. All right, so that's what we mean by a reference number. And what the reference number is going to be useful for is if I need to find the terminal point for some point over here in the the third quadrant. Well, if I can get that reference number, the reference number, since if you look at the distances for our reference numbers, those little black sections that I put on here, the reference number is always less than 1/4 of the circle, right? Never does the reference number take us beyond the y-axis and take us through more than 1/4 of this circle. And so the reference number is always going to be equivalent to a number over here in the first quadrant. And in another video I talked about some of the special reference or some of the special terminal points in the first quadrant. I talked about how you can use a trig hand to figure out those terminal points. Well, our t-bar, our reference number, is going to be one of those points that we know from the first quadrant, so we can use that information to figure out the terminal point for a point that's in the third quadrant or the second or the fourth quadrant. Right, so we take the information that we know from the first quadrant, and then we just kind of reflect it around the circle, making the x or y coordinates negative, depending on which quadrant we end up in, and the reference number is what allows us to do that. Right, so the reference number is always going to match up one of the numbers we know from the first quadrant. All right, I'm going to pause the recording here and erase the definition of these pictures, and we'll do a couple quick examples of just calculating reference numbers. It might sound complicated based on the definition and based on the pictures. But when we actually do some examples, you'll see that it's really not so difficult to do at all. All right, so I put a couple examples up here, and if we have time, we'll do a couple more as well. But t equals 5 pi over 6, t equals 7 pi over 4, and I just want to find the reference numbers for those particular t values. All right, so first thing, when you're dealing with a t value, the number one concern is, where does that take me? Right? If I have t equals 5 pi over 6, remember, we're always starting on the positive x-axis, and I have to travel a distance of 5 pi over 6, or 5/6 pi, around the unit circle. Well, where do I end up? Which quadrant am I in? Not exactly where is the point. Knowing exactly where the point is, like whether it's right here or right there, is not that important. But knowing which quadrant you're going to be in is very important when you're trying to find your terminal points. Right? So we got to figure out, for 5 pi over 6, which quadrant am I going to end up in, and then I can find the reference point, or the reference number from there. Okay, so 5 pi over 6, again, think of that, instead of 5 pi over 6, think about it as 5/6 pi, right? These two numbers are equivalent to each other, right? 5 pi over 6 is 5/6 times pi, or 5/6 of pi. Well, that fraction 5/6, that's less than 1 whole, right? 6 over 6 would be 1 whole, so that would be 1 pi. Now remember, when we're dealing with the unit circle, pi is over here on the negative x-axis, right? That's halfway around the unit circle. Remember, for positive t values, we travel upwards. We go counterclockwise from our starting point over here on the positive x-axis, which is our t equals 0. All right, so we start from here and we travel around. If I go halfway around the circle, that's pi, right? Because remember, a full circle is 2 pi. So 5 pi over 6, or 5/6 pi, that's going to be a little bit less than 1 full pi, right? Because 5/6, that fraction, is a little bit less than 1 whole, right? So 5 pi over 6, or 5/6 pi, is going to be somewhere up in there, right? It's going to be a little bit less than 1 full pi. All right, so this is going to be my terminal point for 5 pi over 6. All right, so again, the key thing when you are dealing with the unit circle and looking for terminal points is finding your quadrant. And what I use is the positive x and y, the negative x and y axis, as my guidepost. Is it bigger than pi or is it less than pi? Well, 5/6 is a little bit less than 1, so 5 pi over 6 is going to be a little bit less than pi. That leaves me up here in the second quadrant, right? As I travel around this way, I have to stop before I get to 1 pi, right? So I stop in the second quadrant, right? 5/6, that's more than 1/2 pi, right? Pi over 2 would be up here, right, which is 1/2 of pi. 3 pi over 6, that would be, if I had 3/6 pi, well, 3 over 6 is 1/2, right? So that's 1/2 pi, or pi over 2, right? So I'm going past pi over 2 because 5/6 is bigger than 3/6, right? So I'm going past pi over 2, but not quite to 1 full pi, right? Because again, 5/6 is a little bit less than 1, right? So, when you're dealing with these t-values and trying to find these terminal points, having some knowledge of fractions definitely helps, and being able to compare, is it bigger than 1/2 or less than 1/2? Is it bigger than 1 or less than 1? Is it bigger than 1.5 or a little bit less? Is it bigger or less than 2 or 2 pi? And that helps you figure out which quadrant you're in. All right, so anyway, all that was just figuring out which quadrant you're in, which the more of these you work with, you start to see the same numbers over and over again. So you start to say, oh, 5 pi over 6. I've done that a dozen times. I know that's going to be in quadrant 2, right? So the more you deal with trigonometry, the more you see these numbers repeatedly, and it gets easier as you go. But as you're learning it, do what we just did here. Is it bigger or less than pi? Look at the fractions, help you figure it out. All right, so for 5 pi over 6, since I'm in the second quadrant, my t bar, right, my reference number is going to be the distance from 5 pi over 6 to pi, right, to get to the x-axis. Well, if I have 5/6 pi and I need to get to pi, what would I have to add to 5/6 to make it one whole, or to make it 6/6? Well, I would have to add 1/6 to it, or pi over 6. So my t bar here is going to be pi over 6, right? Because if I do 5 pi over 6 plus 1 pi over 6, that equals 6 pi over 6, which equals pi, which takes me to the x-axis. All right, so that's the reason why my terminal, or not my terminal point, why my reference number would be pi over 6. Now, the shortcut to that is, for this number here, whatever that denominator is, in this case is 6, your reference number is going to be pi over, just 1 pi over 6. It's always going to work out that way, right? So if my t value was negative 17 pi over 6, my reference number is pi over 6. If my t value is 1,487 pi over 6, my t bar, my reference number is pi over 6. Just when you have one of these fractions here, your reference number is just the pi over that denominator. Forget whatever other number is in the numerator. I promise it's going to work out that way every single time. Right? So, all the stuff we had to do here for finding the reference number, now that I told you that shortcut, we didn't have to do any of that. We just had to say, oh, it's going to be pi over 6. Right? But to do some of the other things we need to do, it's important to know where 5 pi over 6 is and all that other stuff. All right, the next one we have here, 7 pi over 4. All right, so once again, which quadrant am I going to find 7 pi over 4? Well, here's pi, right? So 7/4, again, think of this as 7/4 pi. Well, 7/4, that's bigger than 1 whole, right? It is, right? 4/4 would be 1 whole. 7/4 is more than that. So we're going past pi this time. Right, so we're definitely going past the first and second quadrants. Do we stop in the third quadrant, or will it take us all the way to the fourth quadrant? Remember, over here, this is our 3 pi over 2, and all the way around the circle would be 2 pi. All right, so the question is, do we stop in the third quadrant, or do we go all the way to the fourth? All right, so for 7 pi over 4, well, what about 3 pi over 2? If I had 3 pi over 2, and I want to make it a pi over 4 number, if I multiply the top and bottom by 2 over 2, that's going to give me 6 pi over 4. Right? Just to get that common denominator so I can compare these two numbers, these two fractions. Right? So if I do 3 pi over 2, multiply the top and bottom by 2 to make the denominator 4, I get 6 pi over 4. Right? So 3 pi over 2 is equivalent to 6 pi over 4. But 7 pi over 4, 7 is bigger than 6. So I'm going past here, and I'm going to end up in the fourth quadrant, right? Because I'm not going all the way to 2 pi, because 2 pi would be 8 pi over 4, right? 8 over 4 equals 2, so 2 pi would be 8 pi over 4. So I'm not going that far, but I'm going more than the 3/4 of the way around. So this is where I'm going to end up for 7 pi over 4, is going to be in that fourth quadrant. Right, again, comparing to the x and y axis guidepost numbers, which I talked about in another video I did, compare your fraction to those to see where it ends up, is the way I like to figure out which quadrant I'm going to be in. It works very well for me. Right, and then my reference number is going to be from this point back up here to the x-axis, so my t bar, once again, is just going to be pi over 4. Right, like I said before, just take off that 7. is pi over 4.